Today you're going to learn about interval notation, and more specifically, how you can use interval notation to describe different characteristics of given functions and graphs. First, let's refresh about notation in general. In your math past, you have learned a couple of different types of notations. One you probably don't remember is set builder notation. Now the one that you probably do remember is inequality notation. It's probably the one you're more familiar and more comfortable with because it was used all the way up through Algebra 1. In Algebra 2 and beyond, we use interval notation more than anything. So that's what we're going to focus on for today's lesson. Now, before we do that, we do need to refresh things you already know. When I say inequality, my hope is that you remember 4 different symbols that they pop into your mind. Less than, greater than, less than or equal to, or greater than or equal to. When I was in elementary school, my teacher told me that the alligator mouth, inequalities, the alligator was one of the bigger number. Now, back then I understood that. What I didn't understand was how to know which one was which. Which one is less than, which one's greater than? How can you tell? So I didn't figure out until I was probably in Algebra 1 that everything is from the left's perspective. Now, I know we read and write from left to right. I know we read graphs from left to right. And I even know that we read equations from left to right. But I didn't realize that it's important to understand that we're talking about even inequalities from left to right. Here's an example. If I told you this guy right here. Now, I know that that's x is less than 6. But how do you know that that's x is less than 6? Yes, the alligator mouth is pointing to the x, but more importantly, that mouth is open towards the 6. So from left to right, this is going to be x is less than 6. You can use the greater than symbol to express this little equation, but you'd have to flip the whole thing around. If x is less than 6, 6 from left to right must be greater than all of the x's. Technically, these two expressions are the exact same thing. There's nothing wrong with either one of them. Now, visually, we definitely prefer x is less than 6. It's just easier and nicer and obviously more comfortable for us to work with. If that still gives you trouble and you're not quite certain, then I actually had a different teacher in algebra teach me how I could easily do this. And this is going to be silly, I know, but it's something in case anyone needs it. The less than symbol, every single time, is already an L. The greater than symbol can be easily turned into a G. So if nothing else, you can always fall back on L for less than, and then you can make the G out of the greater than. Now, in Algebra 1, you learned to graph these inequalities. Now that you've refreshed that x is everything less than 6 is how we read that inequality, graphing it is actually quite simple. In Algebra 1, you learned to draw number lines and actually graph and plot these expressions on a number line. You use shading to denote all of the values of your x. So on a number line, let me catch up, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So in Algebra 1, you learned to take the number 6, do an open circle at 6, because you know that if there's no equal to bar right there, then you don't get to include the value that you're talking about. If x is everything less than 6, it literally has to be everything less than 6 and not including it, not including the 6. So you took a highlighter, matte pencil, marker, crayon, and you shaded everything to the left of that 6. because you knew that x is everything less than 6. And that's what that looks like. That's what tells you that. That tells you even all the way up to 5.9999999, but not actually 6. So the difference between less than 6 and less than or equal to 6 is simply an open or closed circle. If that had been less than or equal to, the or equal to part of that inequality would have let you shade in and include the value at 6. So x is everything less than or equal to 6. So x could be negative 100, x could be 0, x could be 5.99999, x could even be equal to straight up 6, but just can't go past it. So, quick refresher, less than and greater than, they're open. Less than or equal to, or greater than or equal to, are closed. Taking what you remember from inequality notation and transferring it to interval notation is just as simple. So an open circle on a graph or number line, that means not included, it gets a parentheses. So instead of an open circle, we just use a parentheses. A closed circle, which means we're going to include that value, it's like the solid circle or the solid line. It's the equal to portion, and it's going to get a bracket. Now, let me give you this example onto the side. When you're reading 2 is less than or equal to x, which is also that same x is less than 6, as an inequality, it ends up being this portion of the graph. Let's talk about why. If 2 is less than or equal to all of the x's, every x we have is greater than that 2. So it's going to be to the right of it. Now, it got a closed circle because it was solid. So that's this portion, and that's shading to the right. Why does the shading stop? Well, in this argument, we also have the other portion of that, the other half of that. That same x, so not only is 2 less than or equal to x, so all the x's are less than 6. Well, everything less than 6, you'd have an open circle, and it would be to the left. So this is called an AND. It's a compound inequality, and we'll talk about that a little bit more in a second. Compound inequalities, you have to have 2 arguments that get satisfied. It has to work in both. It's not just that x can be greater than or equal to 2. Every x that actually makes this argument true has to be both greater than 2, but at the same time less than 6. And that is a particular group of numbers. So, could 0 be in this portion of the graph? Could 0 be what x could be? No, because 0 is not physically caught between 2 and 6. 0 may be less than 6, but 0 is not also at the same time greater than 2. So it's out. Now, that is why we don't have multiple shading. We have the intersection of the 2 shadings. This is what an AND is. We'll do more of that in a second. So in interval notation, all this equates to is a solid circle gets a bracket and an open circle gets a parentheses. Mathematically, this is equivalent to this. There's nothing wrong with either one of those. It's understood that x is everything caught in between where the comma is. One more thing before we move on. Negative infinity and positive infinity are concepts. If a bracket means it's going to be included, can you actually reach infinity? No, you can't. So since negative infinity and infinity can't be reached, they can't be actually hit, you will always use parentheses. In the past, in Algebra 1 especially, you learned about all real numbers, and that was a phrase you would use to show every number on the number line. Well, in interval notation, that would be parentheses from left to right as we read all of our graphs, negative to positive infinity. Okay, more things to know, and then we'll actually start practicing this, and it's going to get a little bit faster and a little bit easier. I'm sorry I've been so slow. So talking about compound inequalities. A compound inequality is an inequality that has more than one symbol. In the case of our second example, you had a less than or equal to symbol and a less than symbol. Now, I called that an and because it ended up being the intersection of our graph. That's really fancy for it has to satisfy both arguments. The other type of compound inequality is a union or an or. You will literally have the word or. This is denoted by a U, a math symbol for union. And this is when you can have this or that. So if the shaded region of all these number lines is trying to communicate what x actually can be, in an or, it doesn't have to satisfy both arguments. It only has to satisfy one. In this example, we see that x is anything less than 3 or x is anything greater than or equal to 7. Well, graphically, that's two different portions of graph. That's anything less than 3. So we would have an open circle shaded to the left, or anything greater than or equal to 7, a closed circle shaded to the right. So could x equal 0 this time? Yeah, x could be 0 because x is less than 3. It satisfies one of the arguments. And because it's an or, it doesn't have to satisfy both of them. Now below it, in our second and example, our intersection, you have x is greater than -1 and x is less than or equal to 4. Well, this time it is not written as one strand of an argument. It could be if x is greater than -1, -1 is our smallest number that we're talking about when you're comparing -1 and 4, so it's going to be on the left. If x is greater than -1, isn't -1 less than all of the x's? And that same x has to also be every value less than or equal to 4. Mathematically, these are the same thing. Written separate or written together, it doesn't make a difference. When it's written together, you do not have to have the word and, it's understood to be there. So if an intersection is the overlap, it has to satisfy both of your arguments. That's why, in this case, it's the middle portion. I would have every x greater than -1 shaded, and I also have to have every x less than or equal to 4 shaded. On a number line, it's the overlap. It's the intersection. That's why it's this middle portion right there. Now, the good news is that's super easy to denote with interval notation. Every x is caught from -1 to 4, and because it's open, it gets a parentheses on the -1, and because it's closed, it gets a bracket on the 4. In the union example, notice that I have two separate graphs of shading. I have every x less than 3 with an open circle because it doesn't include the 3. And I have every x greater than or equal to 7 with a closed circle because it does include the 7. Now, in interval notation, all you have to do is write this from left to right. When you skip over a portion of graph, that's where the union comes in. So from left to right, the shaded region would be from -infinity all the way to 3. That would be the first portion of graph for this union. Infinities always get a parentheses. Comma indicates just the span of space, all the x's where all x's would fall. And then 3 has an open circle, so it would get a parentheses. When you skip over a portion of graph, you do your union. to signify a break, but that there's still more graph to talk about. It's just a capital U. For the second portion of your graph, you would have a bracket with the 7, because you have a closed circle on the 7, meaning it can be included. And then all of your x's would go to positive infinity, because that shaded arrow goes on for forever on the number line. And infinity always has a parentheses. That's how we got this interval notation right there. Okay, let's practice. Rewrite the inequality in interval notation and draw a graph on each inequality on the number line. So for time's sake, we're going to do this a little bit quicker. And I'm going to do just a basic number line, very, very simple. I probably am only going to do the numbers that are important, because I'm pretty sure you already know that everything to the left goes to negative infinity and everything to the right on the number line goes to positive infinity. Okay, here's your first inequality. X is everything greater than or equal to negative 3. I find it easier to draw the picture first and get a visual, and then let's practice translating that into interval notation. So if x is greater than or equal to negative 3, my important number is going to be the negative 3. It's kind of a critical value there. If x is everything greater than or equal to negative 3, would I have an open circle or a closed circle? Because of that equal to bar, I would need to make sure I do a closed circle at negative 3. What would I shade? Well, if x is greater than, that would be everything greater than on a number line, which means everything to the right, everything towards greater values, positive infinity. How would I write that as an interval? You actually have what you need already on your number line. Just remember that the closed circle means bracket, and infinity always gets a parentheses. So the interval for this inequality would be bracket negative 3, comma, infinity. Number 2, x is less than 9. What does that look like? Okay, so let's say we've got positive 9, somewhere over there. Less than, no equal to bar. So we're going to have an open circle at that 9. If x is everything less than would be every number to the left, everything with lower value. So that would mean all the way to negative infinity. So I shade my graph to the left for forever, and I already have what I need. From left to right, you need to do from the lowest to the highest values. If you do left to right, you're never going to mess this up. You have negative infinity with a parentheses, comma, 9, also with a parentheses, not a bracket because it was open, not closed. Example 3, our first OR. ORs are super easy. You really just take them as they are. Whatever happens, happens. If they intersect, that's fine. If they don't, no big deal. If they go the same direction, totally whatever. It's and that you have to watch out for, because it has to be both arguments satisfied to be an answer. So on number 3, it's an OR. No sweat. That's a union. An OR is a union. So you are going to have to use our cute little U symbol. It's also called a union. So x is less than negative 4. Well, that would be an open circle at negative 4, shaded to the left, everything less than. Or x is anything greater than or equal to 1. So if this is positive 1, we would have a closed circle, because it said equal to, and everything to the right. So there is our union. There's our OR. Now, what does that look like? As long as you go from left to right, negative infinity all the way to positive infinity, and you represent each shaded region of your graph, you're not going to mess this up. So from left to right, we would have negative infinity all the way to negative 4 with a parentheses, because it doesn't have a closed circle, it's open, union, bracket, 1, comma, positive infinity, parentheses. The 1 got the bracket because it was closed. It was included. Number 4. Number 4 is an and. It said the word and. That's an intersection. Remember, an intersection is simply the overlap. It has to satisfy both. So we're going to have one interval. It's going to be caught in the middle more often than not. It doesn't have to be, but it often is. Let's pretend like we're going to draw it, and then we'll really draw it. Let's start by sketching and look for the overlap before we make our final decisions. First portion of this compound inequality. X is everything greater than 0. If here's 0 on the number line, everything greater than, now not equal to, so I have an open circle, would be everything shaded to the right for forever. If X is less than 5, here at positive 5, I also would have an open circle, but this time everything shaded would be to the left for forever, because it's everything less than X. So where are all the values where X is greater than 0, and at the same time, X is everything also less than 5? It's the overlap of the shading. So it's everything caught in the middle. That would be what your graph would look like. As an interval, you only have to read from left to right and represent every shaded portion of your graph. So you would have parentheses, 0, comma, 5, parentheses. Be careful, this looks like an ordered pair, but this is actually a domain. These are X values because we're talking about a horizontal axis, the number line, the X-axis. So from 0 to 5, X's are all caught in between there. They can't equal 0 or 5, which is why we have parentheses. The 0, 5 that you see is an interval, not an X, Y coordinate pair. Okay, let's reverse it. Write each interval as an inequality and draw a graph for each. Let's start with the graph, and then we'll go back to inequality notation. Now, interpreting this interval. From left to right, we see that our left-hand value is negative infinity. So I'm already thinking this portion of the graph. I see that our interval is going to stop at negative 8. So wherever I choose to put negative 8, that's where we're going to go. I have a bracket on the negative 8, so it's going to be closed. And I see that I have an interval from negative infinity to negative 8. So this portion of the graph is what's going to be shaded. Now, that would be everything less than, everything to the left of negative 8. So X would be less than or equal to negative 8 because I have a closed circle, because I had a bracket, meaning I'm including the negative 8. Now on to the next one. In this interval, I have bracket 5, comma, infinity. So wherever I choose to put the 5, all the way to the far right would be our positive infinity on a number line. I would have a closed circle on the 5 because of the bracket. And I'm going to shade everything from 5 to infinity. That would be everything to the right. So the inequality would be every X greater than or equal to positive 5. In example 7, we now stumble upon our first compound inequality from this perspective. Now, you can tell it's an OR, a union, because it has the union symbol. We're going to have more than one portion of graph that's being shaded, and that's fine. Just take each as it comes. So for our first portion, we have negative infinity, comma, negative 6 with a bracket. Well, negative infinity is over here. Let's say here's negative 6, and it said bracket, so I'm going to do a closed circle. Everything from negative infinity all the way to negative 6 gets shaded. we pick up with positive 1, and we would have an open circle because it has a parentheses, and we'll then have shading all the way to positive infinity. That's what our graph would look like. How do we interpret that into inequality notation? All you gotta do is use the word or. You've got two split portions of graph, take each of them as they are, and then put the word or in the middle. It's that simple. So for the left portion, you have every value to the left of -6. So you have x is less than or equal to -6. You put the word or, and then you finish up with your right side portion. X is everything greater than, not equal to, because it's open. So x is everything greater than positive 1. There's your inequality. What's neat is that all three of these are the same. They're all equivalent in the math world. So interval notation, inequality notation, and the graph thereof, all good, all the same.